Hello everyone, I'm Naoto Takeda at KDDI Research in Japan. Today, I'd like to talk about event detection and event-relevant tweet extraction with human mobility. In this talk, I will present these contents. First, I will talk about background of this research. In recent years, there has been a great interest in research on event detection. Event detection is to identify the locations where people are gathering more than usual. In event detection, presenting event information allows users to make decisions. In this research, we focused on event-relevant tweets as information about the event. For example, presenting a tweet that includes event information about a local festival and the location where it occurs might interest users. Another example is unscheduled events, such as a train delay. When a user learns that a train is delayed, he or she will consider making a detour. In this research, we propose a method for event detection and event-relevant tweet extraction. There are three data sources for event detection: smartphone GPS, geotagged tweets, and non-geotagged tweets. GPS data covers the entire city, so events can be detected throughout the city. However, it does not include any event information. Second one is geotagged tweets. Geotagged tweets have a small number of event-irrelevant tweets included. But, due to the very small number of posts, we cannot expect the data coverage and extract much event information. Third one is non-geotagged tweets. It is quite noisy, but the number of event-relevant tweets it contains is large. In this research, we propose a new method that uses smartphone GPS for event detection and non-geotagged tweets for event-relevant tweet extraction. A large number of irrelevant tweets in non-geotagged tweets are filtered by combining smartphone GPS and non-geotagged tweets. Next, I will explain about related works. Some researchers computed human mobility from smartphone GPS and detect events. But human mobility does not include any event information, such as event-relevant tweets. Geotagged tweet-based approach can detect events and extract tweets, but the number of tweets is very low. In this research, we use GPS-based approach to detect events, and we use non-geotagged tweets to extract event-relevant tweets. Some supervised using non-geotagged tweets-based approach was proposed. However, these approaches need to train the model using the annotated data, so a large amount of annotation is required for each event. In this research, we extract tweets using an unsupervised method that combines human mobility data and tweet data. I will talk about proposed method. Our framework consists of Stage 1 and Stage 2. I will explain about Stage 1, event detection. Firstly, we collect smartphone GPS in the grid cell and compute the number of people per hour. This process allows us to draw a graph. In each grid cell, past human mobility data is accumulated, we defined normal human mobility by computing the average of past human mobility data. The difference between the current human mobility and the past human mobility is computed by z-score. If the score exceeds the threshold phi, then an event is detected. Next, I will explain about stage 2, event-relevant tweet extraction. Firstly, we collect a wide range of tweets potentially related to the event. So, our method extracts tweets using the POI names contained in the event-detected grid cell. Grid cell POI database associates the grid cells to the POI names they contain. Grid cell POI database is created from an open dataset. Our method extracts tweets using POI names as a query. Next, our method identifies event-related topics from extracted tweets. Collecting tweets include a lot of event-irrelevant tweets. So, our method clusters tweets to identify event-related topics. Specifically, we embedded each tweet with pre-trained BERT model. This allows us to vectorize the meaning of each tweet, as shown in the figure. Similar tweets can be grouped by clustering each tweet vector. Our method uses k-means clustering, and each cluster is called a topic in this research. In this case, we can get 4 topics. From these topics, our method identifies the topics that are relevant to the current event. First, computes the number of tweets for each topic per time slot, and computes the correlation between each topic graph and the human mobility graph. Then, we can select the event-related topic. In this case, we can select topic 3, which is shown in red. Finally, our method scores the tweets. To prioritize tweets presented to the users, we quantify the relevance of each tweet to the event. We use 3 scores to score the tweets: D-score, HV-score, and PT-score. The tweets are extracted in order of the sum of the 3 scores. First, I will explain about D-score. We consider that representative tweets of a topic have similar vectors to the centroid of topic. So, we define D-score. The red dots in the figure on the left show a group of tweets with topic 3. The central star is the centroid of topic 3. The D-score of each tweet is computed by the Z-score of the cosine similarity to the centroid of topic, like right figure. On the other hand, we put hypothesis as event-relevant tweets are more likely to be posted during times when there are more event participants. For example, participants in festival events are likely to tweet while enjoying the festival. So, HV score scores each tweet at the time of posting. Specifically, the HV score is computed by the Z-score of the number of people in each time slot. However, there are cases where HV score is not sufficient. In some events, tweets are rarely posted during events. For example, people don't tweet while watching a live concert. So, we also focus on the number of tweets. PT score scores each tweet at the time of posting. The PT score is computed by the Z-score of the number of tweets in each time slot. We conducted 2 experiments to verify the effectiveness of our proposed method. First, I will explain our event detection experiment. The purpose of this experiment is to verify that the proposed method can detect the events. We evaluated whether each target event was detected or not using our method. We use human mobility data computed from smartphone GPS data. GPS data of users who agreed to provide their location data. Users were from the Tokyo and Aichi prefectures in Japan. We selected 5 scheduled events and 5 unscheduled events that frequently occur in Japan. For example, baseball game, train delay. As a comparison method, we adopted the SR approach, which is a state-of-the-art general-purpose unsupervised anomaly detection method. This table shows the experiment results. The red circle indicates that the event was detected. As a result, our method detected 9 out of 10 events. CM1 and CM2 detected only 3 or 4 out of 10 events. So, we confirmed the effectiveness of using past human mobility data. The proposed method could not detect only one event. This event had the fewest participants and many people were in the vicinity of the venue. In this case, the impact of the event was relatively small and detection proved to be difficult. Next, I will explain event-relevant tweet extraction experiment. The purpose of this experiment is to verify that the proposed method can extract event-relevant tweets. We selected target event from 2 perspectives. First one is the event that affects urban traffic and trigger users to consider avoiding congestion, for example, train delay. Second one is the event that triggers users to consider participating, for example, local festival. As a comparison method, we implemented 2 baselines. First one is simple method B1. B1 extracts tweets based on closeness of their posting time to event detection time. Second one is B2. B2 is the proposed method without event-related topic selection. I will explain about evaluation. Each method extracts 10 tweets per target event. Then, 3 annotators grade the value of each tweet. And each method was evaluated by the number of extracted event-relevant tweets. We defined event-relevant tweets as a tweet that at least 2 or 3 of the annotators could identify the occurring event. And we defined event-irrelevant tweets that at least 2 or 3 of the annotators consider the tweets irrelevant to the event. In the below figure, 8 out of 10 tweets were determined event-relevant tweet. In this case, the evaluation score is 0.8. This table shows the results of experiment. Our method performed well compared to the baselines. In our method, in 5 out of 7 events, all 10 tweets that were extracted are event relevant. Especially, the performance of the proposed method greatly improved for baseball game event. This baseball game event was held at the Tokyo Dome, and live concert events are frequently held in Tokyo Dome. So the tweets always include a large number of live concert-related tweets. The below figure shows the number of tweets for each topic. We can see that topic 0 posted in large numbers. This is because popular artists announced their future live concerts at the Tokyo Dome. So, many live concert topics were posted. Our method was able to identify the baseball topic that was occurring. That's why our method performs better than the baseline. Finally, I will conclude. In this research, we proposed unsupervised method to detect events and extract event-relevant tweets by combining human mobility and non-geotangled tweets. We confirmed the effectiveness of our method based on experiments using real-world datasets. In event detection experiment, our method detected 9 out of 10 events. In event-relevant tweet extraction experiment, our method extracted the tweets with an average accuracy of over 90%. We confirmed that proposed method is effective in POIs where various events are held, for example, Tokyo Dome. In the paper, we automatically determine the number of topics and compare event detection times, if you would like to read it. Thank you for watching.